It's safer to work at a nuclear power plant by an order of magnitude than it is to work in an office building. Radiation is both detectable, it's manageable, and we should expect it to decrease in its total quantity over time. The radiation is helpful to us in the fact that it is very easy to detect. The IAEA is tracking some 80 to 100 different new reactor designs globally. If you're serious about investing in this changing energy landscape, I think you look at nuclear. What does a true zero carbon economy look like in the United States? How would we accomplish that? There just hasn't been a lot of demand to force the market into creating factory platforms to allow them to be built at scale.
Welcome to The Diligent Observer, the first podcast exclusively focused on helping angel investors make better bets. I'm your host, Andrew, and today I'm excited to share an episode from our first deep dive season focused on angel investing in nuclear energy. When three respected VCs mentioned nuclear on this show within a month late last year, I realized that something unique was happening. So I've spent the last 90 days going deep, interviewing nuclear experts, analyzing deals, and just trying to understand what this all means for angel investors. Over 5 episodes, we'll explore what works, what doesn't, and why through conversations with some of the most experienced voices in nuclear energy. The season will culminate in the release of the Nuclear Energy Investing Playbook, which you can pre-order today using the link in the show notes, or get it completely free by subscribing to The Diligent Observer and referring at least one friend. My guest today is Tighe Smith, a nuclear manufacturing and supply chain veteran who has been central to multiple acquisitions in the space. Rather than chasing the latest reactor designs, Tighe brings a crucial perspective on the often overlooked opportunities in nuclear supply chains and component manufacturing. In this episode, we explore how to evaluate nuclear companies' true scalability, examine what makes nuclear M&A unique, and learn why the next wave of nuclear growth may create compelling opportunities beyond just reactor technology. I hope you enjoy learning from Tighe as much as I did. Tighe, thank you for being with me today.
Right, thank you. Great to be here.
Okay, so Tighe, you have been living and breathing this space for a couple of decades now. I'd love to just start with, what are some of the things that are really exciting to you right now in the nuclear energy ecosystem?
Well, it certainly has been a dynamic few years. You know, when I started in nuclear about 20 years ago, really the industry was kind of in a steady state. I might call it a stasis moment. They were generating 20% of the electricity of the United States. Global expansion really wasn't something that was happening very much. And it stayed that way for a few years. And then we had this, what today we refer to as probably the first renaissance of nuclear, where we looked at expanding baseload power with nuclear power plants. That got disrupted. Those plans got disrupted by, kind of the monumental shift in, natural gas and in the fracking industry that shifted the overall cost of producing power lower. It shifted that curve down. And so that had a negative impact on the industry, along with some carryover from the Fukushima Daiichi accident in 2011. So since that time, we've seen, the industry kind of moving in different directions, trying to find its place, really. Where does it belong? What does it look like in the long term? And in that time frame, obviously, the world has shifted towards, I'd say, close to a consensus around the need for clean energy or carbon-free energy. That shift has put a heavy focus on decarbonizing the electricity production in the United States, put a heavy focus on decarbonizing transportation, all of these disruptions within how we produce energy and how we think about energy in a net carbon neutral way. That has had a very positive impact on the nuclear industry today. I think people have done a lot of modeling to try to say, all right, what does a true zero carbon economy look like in the United States? How would we accomplish that? And when you look at those models, you can't derive a stable, like a zero carbon model without a fairly heavy complement of baseload nuclear energy. It's just, you run into these mathematical problems of intermittent resources. And then even with large battery backups assumed, you still don't get to a position where you say we can do it all without nuclear power plants. In fact, most of those models indicate somewhere to 45 to 55% of electricity demand needs to be met by baseload sources in order for us to truly have a stable grid in the United States. So we have that piece, right? The second component that can't be ignored, we're being asked to decarbonize while we're seeing an increase in the demand of electricity in the United States. That's been driven by, of course, the data centers, artificial intelligence, machine learning revolution that we observed in the last couple of years. That's accelerating rapidly. I think the most recent statistics I saw showed that growing from 4% of electricity use today to 9% of electricity use, in the 2030, 2035 timeline. The state of Virginia released that they thought they would need to double their electricity generation by 2035. Now, in some industries, that doesn't sound so daunting, right? But when you talk about high capital cost, high production cost type industries like electricity, where you're constrained by things like where are the wires that go over people's houses, where can we expand, where are the natural gas pipelines, all of those pieces about how difficult it is to rapidly expand something as important to our lives as electricity are really coming into focus and forcing us to look at nuclear in a different way. We know we can build nuclear quickly. We know we can put it in places where you don't have as much available fuel, either fuel for natural gas turbines, or they don't have access to wind or access to solar on a regular basis. Those components, the stability of the fuel supply and the ability of the fuel to move with the reactors relatively easy, make a very strong economic case for why you would use that to maybe site alongside a data center and put the data center where we need it to be instead of forcing the electricity to move to the data center or the natural gas to move to the data center, where you run up into problems of eminent domain restrictions and the complexities of disrupting people's lives and people's property by trying to run new electricity lines or new natural gas pipelines. So I think those pieces of the equation have come together in this compounding effect to really drive people to look at nuclear in a whole new light. We've seen recent announcements from Microsoft, Amazon, Google, Facebook, or Meta looking for nuclear power plants. And those people and those particular tech companies with large balance sheets coming into this space, making investments, making commitments for power purchase agreements has really solidified I think, what we think of as the demand signals within the market. So we're starting to see now our customers at Paragon becoming, really intentional about making sure they have their supply chains well buttoned up, making sure they've got a good plan on how to deliver on the expectations of their customers, ultimately driving demand for all of the large constituent components that make up the nuclear industry in the United States.
So, Ty, one of the things I want to understand a little bit better, expand on what you mean when you say positive influence or positive direction. Because when I look at, the number of reactors and the number of plants that are active in the US, it's all, looking historically, it's all kind of downhill. Yep. What are the metrics or data points that you look to kind of get a leading sense for positive direction? I heard you just mention, an announcement of
Yep.
large projects, but say more about that.
So generally, when I'm looking at the market and kind of thinking about the addressable market by Paragon, we start with a true macro view, thinking about demographic trends. And that macro view is generally driven by what do the people that forecast energy demand for a living, what are they saying about the market? You have great available public resources from the Energy Information Agency, EIA.gov. You can look at all of the different research agencies that are looking at this challenge. And those really indicate a shift in the expectation of the energy demand curves. They indicate that people are going to need more electricity in the future, right? And if you bring in the needs for zero carbon, you frankly just get constrained on sources. You run out of sources very quickly to meet all that demand. So I think when we looked at this, thinking back to the 2016, 2017 timelines, the curve for energy demand was relatively flat. Maybe it's expanding 1%, 2% a year. We were getting incremental gains from energy efficiency. No one had really developed a compelling electric car. No one was sure if that was really going to happen. And all of the rhetoric around zero carbon had really not gained a lot of speed. There are those of us that were still thinking about that, thinking long term that it would, create this opportunity, but it hadn't really reached into the common vernacular of most people in the United States. So over the last 8 years, we've really seen that change. When I look at the White House report that just went out in September, that's nuclear energy liftoff report, it really examines the data pretty closely and looks at these different low, mid, high cases of use. What are they expecting on the bottom, roughly in the middle, and at the high end cases? And all those things have different total aggregate amounts of nuclear energy capacity by 2050. They all show more energy capacity needed than what we have today. That's certainly changed. The other thing that has changed is the pricing around electricity. If the fracking boom is kind of quieted down, we saw the impact. If natural gas producers can export their natural gas and get their pricing closer to what the average global price of natural gas is, that will have it will increase the cost of electricity in the United States, which allows the nuclear power plants to operate at a better pricing margin. So all those pieces kind of come together to point towards this future where energy demand is higher, people are expecting to have capacity constraints, and they're expecting zero carbon to start to decrease the amount of energy coming from both fossil or both coal and natural gas assets.
And another thing you mentioned earlier is that we now have the ability to spin up more nuclear power quickly. When I think about nuclear, I don't think about it as a quick spin up process. So I'd love to understand more about what do you mean by that?
Well, in the world of nuclear, we operate today, and this will be maybe a US centric view. There are a lot of countries that operate nuclear power plants, but we'll talk first about maybe the US utility industry and its current assets. The current 93, 94 operating units we have today were all built, bespoke. They had a relatively common design amongst some of them for the reactor itself and how the fuel goes. But when you move beyond those pieces, the plants look wildly different. They have no common control systems. They don't have common mechanical systems. They're designed differently for on the cooling side. That lack of commonality creates this world where they don't interchange parts very easily and they don't interchange service providers very easily. So that really creates a higher expense load on the plants. And I think they've done a great job operating. If you think about kind of stick building a home, when you build a home from the foundation up, the cost is higher than if you were to buy one that has been pre-manufactured and it's delivered to your house, right? There's a fairly large variance between the capital costs between a mobile home and a site-built house. So the same thing happens with nuclear power plants. What we expect from the folks like NuScale, X Energy, other power producers, Kairos, TerraPower, AP1000 from Westinghouse, the GE BWRX300 from GE, those plants are designed with that foreknowledge. They understand that all those variances in design caused a lot of expense. And now they have moved to a much stronger push towards commonality of parts and the ability to make these components in a more of a factory setting instead of having them to be built out of the ground. You might see in the aircraft industry, right? Boeing has to build new 787 Dreamliners. They build a factory for it. They tool the factory. the capital cost is high to get that factory up and running. But once they are able to get all of that up and running, they have a relatively controlled marginal cost of additional capacity for new planes. And they can continue that manufacturing for a long time to a common design. That's really the model that we're looking at for nuclear is let's get these projects moving. When they're moving, we have that momentum within the supply chain and within the reactor vendors themselves. And you continue that momentum through time and factory build these things, and their expense goes down dramatically. We see that with natural gas turbines today. You can put a natural gas plant in 18 months with a factory built natural gas turbine. Admittedly, probably not quite as complex as a nuclear reactor. But at the end of the day, nuclear reactors, although they require a lot of government licensing and they require safety systems, they're not terribly complex devices, right? They're quite a bit less complex than things like the newest generation of wafer machines for microchips, for example. They're not on the order of the most complex devices that we build as people. There just hasn't been a lot of demand to force the market into creating factory platforms to allow them to be built at scale.
Ty, what are some of the other things that most people don't understand, or that maybe insiders in the industry like you kind of get sick of hearing talked about incorrectly? My sense just getting into this world over the last few months is there's a huge amount of public misunderstanding of how these things work on the safety front, regulatory. Everybody thinks about bombs. Like, what are some of the misconceptions that you see in the market?
Well, certainly, I think people always conflate nuclear power with nuclear weapons. That's a long-term challenge for us as an industry. And frankly, there's good reasons for that. The same fuel that you use to make a nuclear reactor, if you desire as a kind of a state to create a nuclear weapon, that can be an outcome of those kind of factories and things that we build to make sure we have fuel supply. So I'm not saying that those concerns are not somewhat valid. What I do think is people don't understand all of the intricacy at work in the world to prevent people from really expanding weapons programs. We have a lot of stockpile stewardship and work from the IAEA to make sure that we are inspecting countries that do have weapons programs and that we are navigating as best we can the geopolitical environment to ensure that people that desire to have nuclear weapons, that we try to bring them into a kind of a different outcome than putting nuclear weapons together. At the end of the day, we operate the plants in the United States, have an extremely high safety record, right? They are safer. It's safer to work at a nuclear power plant by an order of magnitude than it is to work in an office building. They're very, very safe because they have to be. I mean, you have what we call in our industry a nuclear safety conscious work environment. We insist amongst ourselves as an industry and also the Nuclear Regulatory Commission as the ultimate regulatory authority here. They insist that you train on things like leadership, that you understand how your work impacts the safety of the plant, impacts the safety of the people, and then impacts the safety of the environment. There are very few industries where every worker within that domain truly understands the impact of their work the way that nuclear workers do. And I think that having that level of training and that level of appreciation for safety has allowed us to create arguably the safest way of producing electricity in the world. That has helped us a lot in navigating that. I think some other misperceptions sometimes around nuclear is that they're not very safe to be next to. You get quite a bit more radiation dose by flying from New York to Los Angeles than you do living next to a power plant for 25 years. All of the radiation that we're producing is contained, it's safely contained, and we understand how to control it. One of the comparisons I often make is we've had some recent things in the news about forever chemicals, right? These chemicals that are produced that move into the water supply or move into the soil, contaminate the soil, and those chemicals do not ever degrade. They're going to be around forever. Those chemicals are not easily detectable, right? It's going to have a hard time assessing water. You've got to send it back to a lab, make sure that you can understand what's in there. And they're only specialty labs that can really detect that. Today, you can go on TikTok shop and buy a very simple radiation monitor, and you could tell if there was a piece of radioactive metal in your backyard, you could find it. You can do a home kit and build one out of soup cans and some basic electronics. The radiation is helpful to us in the fact that it is very easy to detect. We've been able to detect it since the 1920s. We've only improved that. And so it's very easy to detect. Once you can detect it, you can go take care of contamination and put it someplace where we know that it's safely contained. The other great thing that we're blessed with radiation is that it has a half-life. Every radioactive isotope in the universe has a period of decay. And that decay means that half-life is going to have half as much mass as it did, whatever its half-life is. Tritium's got a half-life, I think, in 12 years, 11 years, something like that. So there are all these different isotopes that will reduce in the radiation over time. When we think about radioactive waste, it's really a problem of controlling it for some period of time so that it is safer. And that is an important attribute, that radiation is both detectable, it's manageable, and we should expect it to decrease in its total quantity over time. Some of those times may not be on human scales, but certainly in geologic scales, it does reduce in volume and danger to the environment.
Talk about some of the things that, as an investor, you would be focused on if you were considering investment in a company that claimed to be innovating in the nuclear energy space. Like, what are your immediate first thoughts and questions that you would have for that company?
I think as a relatively knowledgeable person in this space, even I have some challenges deciphering all of the nuances of these different companies that claim to be leading innovators in nuclear. I think if I read it right, the IAEA is tracking some 80 to 100 different new reactor designs globally. All of those designs have these interesting attributes. Their coolant is often not water. The coolant is often something like a noble gas like helium, or a relatively low melting point metal like sodium, or it may be a molten salt. Those are the types of coolants that we may expect to see, principally because they can operate at higher temperatures with a overall reduction in pressure that helps contain the reactor safety boundary. You can reduce the safety boundary. So I think when you're an investor observing all of that, you should think about it in a couple of different ways. Number one, I think you need to look and say, do these companies have a plausible customer that is likely to have the money, the capital to build these plants? If you're an investor and you look at a nuclear vendor, reactor vendor, and their customer is a small municipal utility operating somewhere, maybe in the Midwest or something like that, if that utility doesn't have an asset balance sheet available to them of north of $1 billion, they're not building a nuclear power plant, right? They don't have the asset base to do that. So I think you do some due diligence around, does that make sense, right, from the first start? The second part of it, looking beyond the customers that Mark Linder is claiming, is look at the level of innovation required to bring their reactor to fruition. When you look at the NuScale plant, for example, the fuel that the NuScale plant is going to use is produced today at commercial quantities. So we know that NuScale can go out, buy that fuel in a market that is well understood and well developed. And that really helps them lower the innovation cost to get to that point. Some of the other followers of NuScale, like X Energy, Kairos, both utilize a fuel type called TRISO. That fuel type has been qualified by the Nuclear Regulatory Commission. It's been invested in by the Department of Energy, and there are pilot scale plants already delivering TRISO fuel to the industry. Plants that use regular what we call light water reactor fuel today, AP1000 or any AP100 by Westinghouse, the GE BWRX 300, the NuScale plant, the Holtec plants, those plants have fuel that exists today at scale. The next set of plants use fuel types like TRISO that, at least if they're not built at large commercial scale, have a demonstrated path to manufacturing and availability. beyond those plants, you really get into areas where maybe the fuel is not nearly as well developed or as tested. And the Nuclear Regulatory Commission will not allow you to operate a plant at commercial scales and putting power on the electric grid if you have not qualified your fuel. And the fuel qualification process is relatively long. So that's an area where I think you can do some due diligence. Another area of innovation is in material science. So what are the materials that the reactor has to be made out of to allow it to operate at its temperature, pressure, and flow rates that it's indicating? And you run into problems when you start having things operating at extremely high temperatures with somewhat caustic materials. So you got to make sure that you believe that the metallurgy is sound around the coolants. Liquid sodium, for example, I think we have good demonstration that when it's put into the right type of environment, it really has less of an impact on piping systems than water does. You can operate a sodium loop for a long time without having a lot of degradation or flow-induced erosion of piping. So you want to look at that versus things like high temperature gases, where those gases, the molecules are small enough to move into the grain boundaries of certain types of metallic components and create maybe an embrittlement along the grain boundaries. Those are things where, you're like, well, there's not an existing engineering base of materials that will meet the requirements of this reactor. I mean, you got to be a little savvy to do some of that research, but it's out there. And the good thing about the nuclear industry is that most of the information is publicly available. I often point people to the Nuclear Regulatory Commission's website, what they call the Atoms Public Database. That database contains millions of records of discussions that the NRC has had with reactor vendors, discussions around the materials of use, the fuel of use, all of those pieces. That information set is available to investors to look at. And I think with discernment and hard work, really select the right targets for the level of risk that they have an appetite for. So there's a really positive information environment for doing the kind of research required to answer these questions.
Okay, Ty, you mentioned before when we were discussing that you and your company have been through a number of acquisitions,
Yep.
either as an acquirer or been acquired. I'd love if you could talk a little bit more just about those specific stories, what you learned, and maybe any nuances about those transactions that you feel are relevant.
Yeah, we've been fortunate at Paragon to have acquired now, let's see, 4 different businesses in the last roughly 4 years. And those businesses had different flavors. We did a lift out of a publicly traded company. We lifted the nuclear business out of that company. We bought a couple of relatively small owner founders, and then we lifted out a product line from another large publicly traded firm. And they each have their own nuance and challenge. I think one of the things that every investor needs to be thinking about is how fast can an owner founder company scale? So if I'm looking at a company that is maybe got a great innovative product, but they're still in the R&D phase or the kind of early manufacturing stages, what is the infrastructure there to scale at their current location versus what do I think I need? What do I think the market man will be, maybe another 3 to 5 years. And then you've really got to do the work to go in and say, all right, here's the structure that we need from a personnel standpoint to allow ourselves to grow into the market demand. And here's the capitalization that we need to really move this product forward. And there's a lot of uncertainty in that, right? When you buy a company that's, let's say, when we purchased Nuclear Logistics in 2020, we were buying that from a publicly traded firm called AZZ. They had mature processes. They had a really strong quality assurance programs. They understood how to run an HR program. They knew how to do metrics. They knew how to have annual performance reviews. We didn't have a lot of trouble bringing them into the Paragon way of operating versus an owner founder firm where we're coming in and maybe for the first time putting in things like our expectations around key performance indicators, programs around how we're quoting, and the diligence around financial performance. And so that's a different journey for those companies. It is not as easy for a firm that's kind of come from and bootstrapped everything from the beginning to come into an environment where now we're going to have more oversight on your processes, right? So you've got to manage that transition, and there's going to be friction there that you've got to help overcome, particularly as a management team. So for the investor community, your opportunities are relatively small in this space. There's just a handful of publicly traded firms that have a lot of revenue exposure and earnings exposure into the space. And then you've got relatively small startups that are looking at deploying reactor technologies that you may be able to get in on an early seed investments on. The space that's not as often explored between those two relatively large spaces is what in the space that Paragon operates, which is the people that supply components and services to nuclear reactors. There is an entire ecosystem of companies that do the work like we do, which is supply safety related equipment into existing plants and to new plants. And there is a variety of sizes of those companies. Paragon, even though relatively large, we got 300 employees, that's small compared to most markets. There are companies smaller than us that are operating in the same market that we're in. There's also a relatively large group of companies that are more like engineering services firms, and those have a variety of sizes. Some of the largest ones have 3 to 4,000 engineers available for large projects. And then the smaller ones are really guys that had a domain expertise, worked at a couple of different companies, or maybe worked at a nuclear power plant. And then they start their own consulting business, scale it to having 5 to 50 engineers and project managers, and they're comfortable in that area. And then they may look to, as the market is now expanding, look at, okay, is this our opportunity to scale? And what is the capital structure that we need to scale with an industry that frankly could be doubling in size in the next 10 years? Those are opportunities for investors to look at those companies and try to figure out what they are. Networking on LinkedIn. The NRC is another great place to get information about what kind of companies are involved in nuclear. And there are a lot of conferences that are open to the public. The American Nuclear Society operates the Utility Working Conference that'll be combined with the Nuclear Energy Institute's one of their annual conferences in 2025. You can register and come down and spend time really getting a much deeper understanding of the industry versus what you can probably do in a lot of other industries, and start to network and meet people that are also here. There's a guy, his name is Rod Adams, that does some nuclear podcasting. He also runs an angel investment slash early stage investment group that's focused entirely on nuclear. So there definitely are people that are interested in the space that have domain expertise that are trying to put together some investor syndicates to help capitalize on this opportunity.
Tighe, any final thoughts or key lessons learned you'd like to share?
I think I would encourage people not to sleep on this, on the nuclear industry, and to really look at it as from a whole picture standpoint, and try to think about, if you believe or not, do we need to decarbonize our economies? If we do, what does that look like in the next 15 to 20 years? And what are the technologies that are available to accomplish that? I think fusion often attracts a lot of dollars. They've attracted an outsized amount of dollars compared to fission, which is the area that I work in. They have never demonstrated the ability to even build a power plant, much less build anything at scale. And so I do think fusion is a future technology. I don't think it's one that impacts clean technology in a scale fast enough to do anything about global warming. And so if you're serious about investing in this changing energy landscape, I think you look at nuclear, understand that it's an area where you can concentrate your focus and have an area of investment opportunity that to me has not been tapped very well by angel investors, venture capital, or even private equity. There are opportunities in the space to make those first investments, to invest in people and management teams that understand how to manage these businesses. You can invest in reactor vendors where you do the work and look at the technology platform and say, hey, these folks have a mature fuel technology that they can use engineered materials that are in common use or relatively common use in other industries. They don't have a lot of engineering or physics related challenges to get to market. Their challenge is capital, their challenge are human resources, things that can be overcome with investment. And so I think those are important areas to look at. I'm excited about it. I've spent 20 years in this space. I expect to spend another 20 years contributing here. People in the nuclear industry work for a long time. It's not something you typically leave. And the reason is the people are passionate about it. If you're serious about making sure that you're leaving the planet better off than when you came to it, nuclear is a great place to put your time because you know that you're delivering something that's safe, doesn't impact the health and safety of the public, and that ultimately creates these high paying jobs with strong economic benefits to the communities where these reactors sit. They require a lot of people to work at them versus coming in and putting up a wind farm or putting up a solar farm that require no people to really work on it. So there's a strong community incentive and community participation in nuclear. All those pieces really provide both, I think, some of the justification for investment in the space. It justifies why the political climate is positive towards nuclear. And all of those pieces really come together well to create an interesting landscape from an investment standpoint.
Love it. Well, Ty, we will wrap there. Thank you so much for joining me today. This has been tremendously helpful. Very grateful for your time.
I appreciate the opportunity to talk about something I'm obviously very passionate about.
Thanks for listening to this episode of The Diligent Observer. I'm your host, Andrew Taslow, and if you are looking to make better bets as an angel investor, subscribe for more at thediligentobserver.substack.com.